Okay, so although these dot plots don't give you those five uh, data point statistics, the mean, the median, the upper quartile and the lower quartile and the range, like right away, you can figure it out with these with a dot plot. And we have two different dot plots to show how this outlier here affects the information that you get from the data. Okay, so and also affects what you're gonna pick. All right, so first things first, let's figure out the median of data set one, or test one. And the way I'm going to do this, how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. So n equals 24 for this one. And n over here is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 25. N equals 25 for this one. All right, so that's the number of data points. Okay, and something you can look at right away and notice that this has a more bell-like curve distribution than this one does. It kind of does like this, and it goes not bell-like at all. If you have a good distribution of data, it looks like a little bell curve, right? So this is affected by this outlier here. This actually looks like we have two little bell curves into one, right? So let's figure out what the median is, right? So to figure out the median, we have to take 12 off of here and 12 off of here and figure out where the middle point of the data is, okay, based upon the median. That's the number of data points, right? So 24 divided by 2 is going to be 12. So we're going to take 12 off of this side and 12 off of this side. So when I'm going down from 100, I'm going to mark down from the top. And when I'm going up from 65, I'm going to mark off from the bottom. All right, so let's do 3 off the bottom and then switch colors and go 3 off the top. 1, 2, 3. All right, and then let's do another 3 more off the bottom. 1, 2, 3, and then another 3 more off the top. You can do this one by one. I just don't want to because that's going to make me have to shift colors more often on this program. Okay, so now it starts to get a little bit less easy, I guess. All right, let's go from here, and we're going to go off the bottom. 1, 2, 3. And let's take off 3 off the top. 1, 2, 3. And then let's go, let's do like 1, 2, 3 off the bottom. And then 1, 2, 3 off the top. So right here is where the two meet. Right here is where the two data points meet when we use that method, right? So the way to figure out what the median is, you add 85 plus 85 and divide by 2, and you'll get the median. Median is 85. Okay? So now we have to figure out the mean. The mean is going to be a little bit more arithmetically challenging because we have to multiply stuff a bunch, right? So to find the median, the mean, which is the average. Yeah, the mean, which is the average. We are going to count all of these up by multiplying. So 1 times 65, 70 times 2, 75 times 80, or 75 times 3, 80 times 5. And when you do all that arithmetic, you get the sum of all these points is 1,190. 1,990. right? That's just from going 1 times 65 is 65. 1 times 70 is 140. 75 times 3 is 225, and so on and so forth, and then adding all those sums together to get 190 or 1990. And then we're going to divide that by 24. And that equals about 83%. About 83%. Let's change these equal signs to an approximate sign. Approximately 83%. Okay. Or 83 is the test score, presuming that it's in percentages. All right, so now we figured out the median, the mean. This is the mean. It slipped on me. This is the mean, also known as the average. Right, but now let's figure out what the interquartiles are. Right, so half of the lower data set is quartile 1, and half of the upper quartile set is quartile 2, or 3. Right, so quartile 1 is going to be down here somewhere. So just like we did before, we're going to start counting at where our data set split downward. Okay, so it's going to be 1, that'll be 1. Here is 2, here is 2 total. Okay, and then 3, 4, 5, and then these two here is where the quartile sets. It's like in between those two numbers. So 75 plus 80, 75 plus 80 is 155, and divide that by 2. So 75 plus 80, that's from these two numbers right here. And then we're going to divide that by 2. That's 155 divided by 2, and we get the lower quartile at 77. Quartile 1 is 77.5. It's a big 5. Now we're going to do the same thing for this data, right? We have to start here, work our way back. 1, 2, 3, 1, 2, 3, 2 more, 2 more, and then right here is where the two are going to meet. All right, 90 plus 90 is 180 divided by 2 is the quartile 3, the upper quartile, equals 90. So what is the interquartile range? The interquartile range. That's the range between the two quartiles. That's the range between this number and that number. All right, so 90 is going to be 90 minus 77.5. And we will get from that 12.5 interquartile range. Okay, so that is all the really good information from this test. Okay, now let's do the same thing for this one over here. Let me pause it while I readjust the screen. All right, so now let's do the same thing. Let's figure out, the first thing we did, we figured out what n was. We did that right away. Now let's find the median by using that same methodology. Right, 25 divided by 2 is like 12 and a half. Right, so we really can't do 12 and a half, but we will count down here, and that's going to give us, we're going to land actually on a number that is the median. We don't have to divide anything. Okay, so what we'll do is we'll go from left to right, up to down. Okay, so that's 1, 2, 3, 4, 5, 6, and let's switch colors to 1, 2, 3, 4, 5, 6. Okay, and now let's start whittling it down. Let's do 3 of the other ones. We'll do 4, I guess. 1, 2, 3, 4, and then we'll do 4 on the other side. 1, 2, 3, 4. Okay, and then we'll do 2 more. I'll do the same process, I guess. All right, so 1, 2, and then down here will be the other blue numbers. 2 more. 1, 2. So right here is my median at 85. The median equals 85. Okay, let's do the quartiles. So we'll do quartile 1. It's over here somewhere. And quartile 3 is over here somewhere. Okay, that's quarter 1, quarter 2, quarter 3, quarter 4. So the quartiles are up there. Okay, so now what we're going to do is the same process as before, except just focusing on this side. All right, they're both going to use this number. They're both going to use 85. Okay, so actually, that doesn't really matter if they do or not. So let's see. It's not asking us for the quartiles, but we'll do it again. We'll do it some more anyway. All right, so the quartiles here are going to be, we're going to count this one. We're going to go 1, 1, 1, 1, right there and right there, right there and right there, right there, and whoops, and right there, and like there. So right there at 75 is our first quartile. Okay, our upper quartile is going to be the same process. That one, then that one, do that one, then that one, and we'll just keep doing that process. And until you find out that right there is our upper quartile at 90. Quartile is 90. Okay, and so our interquartile range goes from here to here, which is 90 minus 75, which is 15. All right, now how about the mean? All right, so I'll show you how we added this up before. All right, so we'll do mean in like this color. All right, so 55 times 1 is 55. 70 times 1, 2, 3, 4, 5. 70 times 5 is 350. Just double checking. Yep, so this will be 350 points earned by those people. 75 times 4 is 300. 80 times 2 is 160. 85 times 5 is 425. 90 times 4 is 360. 95 times 2 is 190. And then 100 times 2 is 200. Then we'll just add all those up. So we're going to do 200 plus 190 plus 360 plus 425 plus 160 plus 300 plus 350 plus 55 is 2040. So 2040 divided by the 25 from the n. This divided by that is 25, and that's gonna be 85. 85 for the mean. Okay, so let's go down and see what other questions we did not answer. Okay, we figured out the mean for test 1. It's right there. We figured out the mean for for the median for test 1. It's right there. Okay, which is most appropriate to describe the measure of the center point. So let's talk about measure of the center point real quick. All right, so the measure of the center point, such as a mean or a median, are used to describe the typical value in a data set. So you're looking for the typical data in that value set, right? And you kind of look at which one you want to use based upon the variation, right? Either by the range or the interquartile range, right? So the range for this one was from 55 to, so the range for this one is 65. The range for this one was 45, because it's 65 to, or excuse me, 35, 65 to 100, right? So this one has a much smaller range, indicating that the data is more evenly distributed, okay? This one has a much larger range, right? Indicating that the data is more erratic and spread out, and it may even have an outlier like that, okay? So what's the most appropriate to use to describe the center point, the mean or the median? Well, in this case, it's going to be the mean, because the data spread is low, right? Also, you could also say the range is low, right? Or the data is relatively close together and compact, okay? We already found the interquartile. We found the mean of test 1 and median of test 2. Okay, now which is center point most appropriate for test 2? Well, in this case, it's the median, because of all the things we just described, but opposite. Okay, you have a very large range. When you have something that covers a very large range and the data is like kind of spread out, a median is a better indicator of what that is. Okay. In this case, the median and the mean were the same. Oh wait, no, this is not right. This is 81.6. So you're looking at 81.6 versus comparing to 85, right? This average was drawn low because of this outlier right here. Okay, so a median is a better representation of the data. Okay. When a sentence comparing, we already talked about all that. So that's like number one. Test 1 is fairly widely distributed, like right here, or fairly evenly distributed, whereas test 2 is widely distributed. So when you have a widely distributed data set, you want to use the median. If you have a nice and compact data set like this, it's a bell curve, right? You want to use the mean. Okay. All right, so here's histogram. Which measure of center would be? Well, this is obvious. This is the median, right? Because look how spread out the data is. We got some all the way up here at 40, and we got all the way to 74. And there's some gaps in the data right here. Some gaps in the data. So we want to use the median. This is a very skewed data. Skewed, meaning that it's not nice and compact. It's skewed by some outliers. Okay, and then the table values and heights. What does that show that? Okay, so the height means the mean is 61 inches and a standard deviation of 1.4. Standard deviation of 1.4 inches. Right, standard deviation of 1.4 is pretty low. Standard deviation is how far from average is each point. Okay, students have a high range between 59.62.4. Let me give you a better definition for standard deviation, also known as sigma. All right, so standard deviation is like a number that represents how far the data is skewed from the mean. Like, so if you have a large standard deviation, it is going to be more compact data. A larger a larger deviation is more compact data. A smaller standard deviation is more spread out data. Okay, so the average student's height range is 1.4 inches, right? So the mean or the average, right, it lies somewhere between 61 plus or minus 1.4 inches, right? So the range that gives you is 59.6 to 62.4 inches, right? So this is what the standard deviation is telling you. It's like you could say, in fact, you could say that the student's height is 61, the absolute value of x minus 61, which x is the student height, equals 1.4. So that's an absolute value function in the form of standard deviation. That means that the student's height is going to fall between 59.6 and 62.4 inches. So a little bit of stuff from last unit come back around. I hope that one helps.